We all have a story to tell. Let's tell yours. Welcome to the Intellectual People Podcast with your host, Jason. Come together and listen to journey stories and more from interesting people. Welcome your host, Jason.
Welcome to the Intellectual People Podcast. I often post on forums, and I'd like to personally thank those forum owners for allowing me to post on those forums. In no particular order, they are audiosciencereview.com, audiocircle.com, audioshark.org, audiofilestyle.com, AV Nirvana, which is also the home of Room EQ Wizard and AudioLens, DIYaudio.com, gears.com, and Parts Express Forum. Thank you so much and enjoy. Welcome to the Intellectual People Podcast. Today I have Bill Dudleston from Legacy Audio. How are you doing today, Bill?
Very well. How are you?
Very well, thank you. Bill, what is Legacy Audio?
We are a unique audio manufacturing company that specializes in a very high performance audio equipment, and we sell to multiple sectors in the industry, from consumers to home theater enthusiasts, high-end audiophiles, pro industry, recording studios, and professional installations. So we do a wide range of stuff.
How did you get involved in speaker design?
I would say that recording got me there first. I loved to make recordings as a kid, and I had two open reel decks by the time I was 17 years old, and thus my affection for all the microphones that we were just talking about. But the bottom line is that I was interested in building audio equipment for experimental purposes. For example, I remember building a reverberator circuit to kind of generate ambience for surround channels before this stuff was really around. And the loudspeaker side of it, I was fascinated. There was a place called McGee Radio in Kansas City, and they had this ginormous catalog of woofers with a bunch of numbers next to them. So I had to learn what those numbers were all about and those parameters. And I ended up I built a loudspeaker as a high school science project in electronics class, and that was my project. And I delivered a paper on turbulence in ports, and how a port with a larger flare could reduce turbulence, and I put it on a bottom loaded port so you wouldn't have to hear the chuffing noise. And I'll be doggone if it must have been 20 years later, Matt Polk actually developed and patented the same thing. And so just kind of interesting, but it worked.
Were you a musician as a child?
No, I love music, and I couldn't stand to listen to myself if I were. All I can tell you is that my expectations in music, and the beats I hear in my head, and the harmonies. I grew up loving the sound of, say the Beach Boys or anything that had a driving rhythm to it. And early rock and roll. I like crooners. I liked from Bing Crosby to Elvis. I just liked anybody who could really sing. And so, I think that probably my inability to perform music, I enjoy singing and stuff, but my inability to actually carry it out through my own fingertips is probably one of my chief motivations for being so deep into audio.
You mentioned that you like to record. What did you record as a child then?
Anything, everything. It could be trains, it could be people, it could be radio programs, mock up. There used to be a show called Mystery Theater, and I used to make, in a college project, I made an episode of a Mystery Theater program. And so that type of thing was a lot of it. Now, as far as music goes, I recorded anything and anybody I could ever get close to. So I have just boxes and boxes of open reel tapes that I've captured. And I've recorded some interesting characters from, I think about, I even recorded Elvis. Okay. So,
Really?
and come to know Bill Porter, and who recorded a lot of his stuff. And I've been involved largely in mastering situations where we're trying to get what I'm going to call a reference quality sound. And I remember Mark Levinson had a project, like 20 some years ago, that was with the Stradivari Violin Society. And we were the reference speakers in that gig. And it was about mic placement and trying to do over and under documentation recordings of of violins, a series of violins that are Guarneri and Strad instruments that we're trying to archive. Now that digital, long-lasting digital recordings are theoretically less fragile than analog. So the advantage of that was that if you could record that stuff, you could archive the sound of these instruments before they're reglued for the third time. And so most of those instruments have had some pretty significant overhauls on them. And by the time you take the backs off and reglue them and whatever, and obviously they've been restrung with catgut a bajillion times by now, and the tensions in the neck are all different. So all of that would affect, the character of the instrument. So I found that kind of thing really good. Mark Levinson was in charge of the capture of the sound of that, and used an over and under technique on the microphone. So,
Are you still into recording?
yeah, I have a studio here that's pretty nice. It's pretty good size. It's about I have a live room which is about 1,500 square feet, something like that, can be adjusted. And knowing the principle of reciprocity at low frequencies, I set up the recording console in the opposite adjacent corner of where I'll call the performance stage when there's an actual band to perform there. And it's set up. It was one of the first true 5.1 digital studios that I've ever saw. And it was when Ramza came out with through the Panasonic brand, I believe they came out with a 5.1 console that with flying faders and 32 channels and da 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 da. So I ran thousands of feet of mic cable and stuff all over. I could go from my mastering suite to the recording venue to the stage, and everything was all plumb. So I had this little selfish period, you might say, that I just kind of indulged myself.
Right. Are you still involved in it? Or
Not nearly as much as I'd like to be honest with you. And I'm one of those personalities that just doesn't retire. I don't know how much trouble I could get into if I retired, because I would start up something else up, and my wife would be very angry with me, I think. But when it comes to projects and developments and just in general hands-on audio, I love the listening, hearing, turning the knob, and influencing the result. And my whole body of life's work in loudspeaker development has been along the lines of wave launch reconstruction. And what that simply means is that if you follow Allen and Blumlein's early patent descriptions on the stereo process, it's a known compromise setup where you don't have a center, you have a left and a right, and you simulate a center by panning and by feeding from left and right. And what's funny is Blumlein, even back in the old days, he described a situation where you had a microphone overhead, two strong left and rights, and from that, and then you could add a center channel also to stabilize the middle. But from that pyramid-like shape, if you will, you could recapture 3D space. And he made some early recordings that he had to invent the stereo recording process, more or less, so he could demonstrate his theories. But and that, is kind of where I think sometimes we've lost our way in audio. I love every time Atmos comes out with telling the consumer that, hey, you need 6 more speakers. Oh yeah, all right. Well, the reality of it is that we hear with 2 ears, and amplitude over time are the parameters. And with 2 channels of audio, you have just 2 levels of amplitude in different time relationships. And I remember early attempts. I know Bob Carver's a brilliant guy. Came out with the process of, I bought a sonic holography, and it was a way of channeling crosstalk back. Some of it was actually a subtractive technique, but he also did some clever equalization. And I also remember when Polk Audio came out with their SDA series loudspeaker, they had a interconnect cable that ran between the two of them, and it was designed to crosstalk cancel. At least that was the concept, the promotional concept. But that is about as theoretically incorrect as you could possibly be, because stereo is predicated on the interference effects between the left and right ear. So, but I followed his paper carefully, and what he was saying was what he said he was doing, and the spread of the speakers being offset left and right did allow you to get a 3D effect, if you will. But it was mostly due to L-R content that you got a sense of spatialization that was somewhat pleasing. But on some recordings, it would sound like you're in a tunnel. So,
what was your degree in college?
It's kind of funny. I married the smartest girl in my physics class. In fact, I think she might have been down to the last girl that was in the upper level classes. But, they were all peeling off as nurses, and she wanted to be a doctor. And so she was taking it to another level, even beyond the others. So she pushed me in the educational direction more than I pushed myself, I think, because, my gosh, she ended up with medical certifications in pediatrics, internal medicine, emergency medicine, med peds, so on down the line. So that's a lot of testing and certification that's gone on all through her life. And she still has to take tests regularly for all the stuff. But it gave me access to anatomy books and gave me access to a lot of great content and stimulus for research, because we get these physiological things about hearing and whatever. And so I would just read all that stuff that I could and try to learn what I could,
Sure. Is your wife still practicing then?
She is, yeah. And she's, I don't know, at the age of she's matured in her position to the point I don't think she wants to do a whole lot more of what she's doing right now, which is this COVID thing is taking a lot out of the energy of doctors, I can tell you. But she's put so much effort into that and keeping people safe, and that I think she's ready to do something that requires a little bit more brain and less just precaution.
Does she have any interest in Legacy Audio?
Oh yeah, definitely. She's my partner. Yeah, my father-in-law was my partner until he was 77, and then in 1997, he retired out, and I partnered with the Allen Organ Company, and that was a smooth operation there because it benefited both companies. One is that they were a maturing world's largest organ company, first of all, but it's, people say, well, is that like a buggy whip? You're going to the last buggy whip. Well, they are the ones that invented the electronic organs that we have today. And there's other brands like Rogers or whatever, but nobody was anywhere near doing what Allen was doing. And they had tendered an offer towards my company. I went and visited their facility in Macungie, Pennsylvania, near Allentown. And what just amazed me was that they were already doing 15 channels of surround sound, if you will, with all the pipes and reeds and so forth. And they were simulating or reconstructing the sound fields of what they could get from recording an organ live. And so that means you go to Notre Dame or Grace Cathedral in San Francisco or whatever, and you get a chance to learn about convolution and deconvolving things, and what is fed to the loudspeaker is so different than what you hear acoustically in these giant venues. So if you go to a giant cathedral and try to reproduce the sound of an organ, you'd be amazed what is coming out of the pipe or what's coming out of the loudspeaker and how different it sounds than what's actually being heard by the observer.
Do you feel as though your experience with recording has helped you develop speakers?
Oh, yeah, definitely. Yeah. My degree was in chemical engineering, and Um, that was a blessed opportunity for me because I was required to take mechanical engineering, electrical engineering, chemistry. I supervised an engineering research lab for a while in digital electronics, and it was a calibrations thing where we had to use linear regression to develop algorithms. And so there was a lot of just a wide range of experiences that this all just kind of tied together, sewed the whole thing together. So,
How long after college did you start Legacy Audio?
I was out of college. Yeah, I'm trying to think about it because I was actually had founded the company pretty early back in '83, and I graduated from University of Illinois in '81 with a bachelor's in chemical engineering, and but it was within a couple of years that my father-in-law, who was an entrepreneur, he had already started 7 or 8 businesses of his own, and his thing was getting them up, pumping and selling them. And then he ran into me, and I just wanted to keep pumping it. So keep seeing how far we could take everything. But the company itself started back in '83, and it was really the first 2 years were really more of a research and educational period for me, where I was just locked into oscilloscopes and measurements and loudspeakers. I remember I had quite an elaborate audio equipment rack when I worked at U.S. Industrial Chemicals. When I first got out of school, they had an equipment rack like you would see in a chemical plant, which was kind of a floor to ceiling kind of thing.
Right.
And I had stuffed that thing full of everything, even a vertical linear tracking turntable from Mitsubishi. And I remember selling all of that so I can just buy test equipment. And that was, to this day, I bought that stuff back because I couldn't stand it, that I had to get rid of it. But I'm now going eBay and go, there it is, I'll buy that. I can kind of relive that period again. But as far as the equipment and all that stuff, it was always the fun of the equipment that kept me excited or motivated, in that it gave you control and be able to experiment, do sound on sound, and bounce tracks back and forth, and having two decks that you could bounce tracks from. It was pretty cool.
Would you say you're more passionate about the technical part of how and why rather than the actual finished product of a speaker?
I would say it's probably, I would say I spend 70% of my day assuring quality in the factory. Nothing leaves here without me hearing it first. And I have trained guys that have worked with me for years that have really, I have a young man with tremendously good ears. And my daughter has joined the company about 7 or 8 years ago. And she's got a very good ear also, but she's into the minutiae side of the business that I try to avoid. But she's very detail oriented, whereas I like to look at the big picture, the big scope of things. But
what is your daughter involved in exactly then?
She runs the office, basically. When I say the office, I should say the total operations here, in terms of what was sold, what needs to be built, and what's shipping that day.
Got it.
And so she pretty much directs what percentage of my day gets spent where, largely because she keeps track of the total picture. And but as far as get back to your question about the listening versus this versus that, I spend 2 hours a day doing hypercritical listening. It would be like if you're matching a pair of microphones. Well, this is matching a pair of loudspeakers, and we have a very unique process in how we do it. And that is, we have a left speaker and a right speaker that have already matched the mother response, the target in spec. And then we tweak them until they sound as close as you possibly can. Now you've got two ears, you got a loudspeaker playing, and every time you play it, it's going across to both ears. And I'm trying to do it in an environment that's somewhat realistic. I don't want, so I've got a room that's about 14 by 20, and the liveness of that room is tuned to represent that of a typical living room. And so when we're nulling these speakers out, matching them, I'm taking into account their power response, how they're engaging, the boundaries around them. We put them close together, side by side, and then we get the equal path link to the microphone. And then we'll actually throw one in phase, one out of phase, and try to get one to cancel the other one as deep as we can. And that nulling technique is extremely useful, because you can have two loudspeakers that look like they measure identically. And when you look at the amplitude response over time, throw one out of phase, and you could have polar tilt that made that speaker totally different in an acoustic space. And so an example of that is I could take a first order crossover network, not to get too crazy technical about it, but I could throw the tweeter in phase on one, out of phase on the other, put the microphone between them, and if it's time aligned in the tweeter response, it's going to measure essentially the same at that mic position. And yet, if you stood up, one goes dull and the other one goes bright. And if you sit down, it's the other way around. Or you let it sit on the floor, it'd be the other way around. So, so there's an awful lot to understanding polar patterns. Now, I think the breadth of my education in physics and so forth has been a great help and been a tremendous advantage. Chemical engineering is, you have to understand hydraulics. And I think of hydraulics, I think of Earl Geddes, who you obviously know. And I was telling my daughter earlier today that I'm a huge fan of Earl because, first of all, he understood Whisper, our highest directivity controlled loudspeaker in the world. He understood that before anybody else. And when everybody thought Dudleston's nuts, he started building his own. He started building his own directional loudspeakers. And what's really interesting is this was in 1995. Pro Audio has taken what I did and ran with it.
Right.
Line arrays, Vertec arrays from JBL. They even had a differential array that had a spine that hung behind the frontal array, the J array, that could give you a differential wave launch, and which is exactly what Whisper did. And I got the concept of how to fabricate this thing from Harry Olson, but I got the why from Alan Blumlein's original work in 1925, and then applying that and wondering, why aren't we trying to actually reproduce stereo instead of what we're dual channel playback kind of thing. So
I have a couple of questions. Let's start with the first one of controlled directivity. Are all your loudspeakers controlled directivity loudspeakers?
Yeah, one could say that the best way to describe directivity is you want broad range uniform directivity. And if you made a truly omnidirectional loudspeaker, that could be called controlled directivity. So it's the term itself is loosely used. And what I like to do is say that I'm looking to try to build a speaker that has uniform directivity as far down in the spectrum as we can. And that's what Whisper just kicked the world's butt with, because it was giving you 20 decibels of bass directivity, and that was just unheard of. Nobody had ever achieved more than maybe 6.
How do you design your loudspeakers? What is your design process?
You know, I would say that has been pretty consistent over the years, and it's really based on acceleration and transient response. You know, there's certain fundamentals that Paul Klipsch laid out pretty clearly years and years ago, and then he was dead on the money, and that is that you better have piston area, because distortion is proportional to the displacement. So if a woofer's got to move very far, you either have to have a really big one or multiple still pretty big ones, and your displacement basically is going to really affect or influence the design itself. Now, as far as how I design them today compared to then, I think it's virtually the same, and that is that I just have a much nicer toolkit to work with. Between, and why did I partner with Allen Organ Company? I should add that in here because I wanted their DSP. They were the world leaders in DSP. They licensed Yamaha's instruments to them. Okay. And then when Yamaha tried to move ahead without them a little bit, by paying their dues, they got sued and they won. And so I love Yamaha today. They're still one of the best technological audio companies in the world. But in looking at the way that we develop things, my goal with Allen Organ Company was I wanted to develop the first digital mixer. Now, to get my way there, they were pretty good guys at Allen, and they were anything that was moving things forward, they were in favor of. So I was able to work with a guy named Olivier Lemouchet, who worked, I think he's still with Line 6, makes stomp boxes for guitars and stuff, and where you can make something sound like something it's not. Well, he was an absolute DSP wizard, and I was able to get a 20-bit digital 8x-channel digital matrix processor developed that I could use to use as active crossovers back in 1998. And that was way ahead of the game. Now, Clark Technic was starting to get into trying to develop that sort of thing. Ashley Portilla.
Yep.
I used all of those things, and in fact, I'm looking at two of them right now. But the key was, if you can picture having a wide number of channels, whether it be 4 or 8 or 16 of inputs, and here again, my pro influence of why you'd want to have that many inputs in multi-track audio, and then you could divide it in how many outputs. Well, my typical high-end speaker I build today has 8 outputs for a pair. And because by the time you look at the subwoofer section, you look at the mid-range, the treble section, and then if you're going to use some sort of steering array with differential where they're firing in a sequential pattern, it takes a lot of channels. And with DSP, you get control. So,
are you all DSP today and no more passive crossovers?
Oh, I wish that were true. No, I probably spend 80% of my day in the analog world still. The DSP but I model everything in DSP first.
You do?
Because, yeah. And so if I'm going to develop the target function for loudspeaker, I'm not going to sit there and play with chokes all day. And now when I get what I want and get the filter shape that I want, then I'll replicate what I do by winding turns off chokes and just show what one of our passive crossovers looks like, a pair of crossovers for a Focus loudspeaker, which is our biggest selling speaker today. It's been our biggest selling speaker since 1995, I think, 93. And, but to this day, we just keep quick as we can put the screws in them, they're out of here. So,
are you a proponent of less crossover parts is better?
I would say it's kind of like, this is one of those answers that Einstein had the best solution to, and I think he picked that up from somebody else, but was that it should be as simple as possible, but no simpler. And when you look at complementary filters, if I were crossing over 2 identical 4-inch drivers in the passband, central passband, say, at 1 kilohertz, and they're going to overlap, and I'm going to make a crossover, and they were both smooth in impedance in that region and whatever, you could follow textbook crossovers. The problem is that gets you nowhere in the real world when you're using an 8-inch driver whose axial response is changing dramatically as frequency rises, and there's also accumulation of phase that you have to deal with in the driver's passband, and you have group delay. Then there's complex impedance issues that you have to look at. So passive crossovers, when I get done with one, there's a lot of parts on them. And I remember when Jim Teal did a true first order loudspeaker that I think the impedance of the speaker was 1 ohm when he got done with it, because he had to send so much to ground to try to get it to behave as it should. Um, and he did it theoretically correctly too. I mean, everything was all aligned and all that jazz. So it was a very thoroughly thought out speaker. But yeah, there are just a bunch of parts on there. And every time I say inductor, I think the word choke, and choke is a bad word because it's doing something. It's choking power, for one thing. Not just high frequencies is what you're applying it to choke high frequencies out. But the reality of it is that it's sucking power. And if you have a 20 millihenry choke, you're going to have, anywhere from an ohm to 2 ohms of loss. We use very high quality bobbins and large gauge wire, and we still end up with up to 1.2 ohms of resistance just in that choke. Now we try to compensate for that by using enormous motors. So we have low QE on our woofers, and which is going to compensate for the resistive losses. But it's still, you don't have the control what you do with DSP.
So if you could have it your way, you would use DSP on every pair of speakers.
Yeah. And the market is such that there are people that are even young people that are analog guys. And, that's an argument that could just go around in circles again and again and again, because by the Nyquist theorem, once you've oversampled double, the sampling rate is double what you can hear, you should be there. But the reality of it is that we have to build in the real world DACs, digital analog converters, and those are quite imperfect. That one of the things that's been developed recent years to try to make digital sound more analog are basically apodizing filters. In the apodizing filters, it's sort of like oversimplify it. Say you apply a first order filter to try to take high frequency ringing out of the bandwidth. And I remember Pioneer had their legato link circuitry and whatever. But apodizing, when you apply it properly and you do correct things in the time domain, you picture a pulse response, and I'll do it backwards in perspective. But if I have an impulse and it's going up like, I'll get it on the camera here, going up like this, and then back down and off the spectrum like that, the reality of it is you get all these little rings on both sides of the impulse. And so your ear will not hear the rings that follow the impulse because it's so masked by ambient conditions and the driver's inability to respond to those frequencies so much with after a large stroke. But the pre-ringing is very unsettling. And once you remove it and then you compare it, the guy who thinks analog and digital sound exactly the same is in for a lesson, because when you make the digital sound more analogish, you have definitely made a substantial improvement. And there's so many camps that people want to just set up camp in, and if you're not willing to continue to learn and get better and better and better, and sort of like how they keep learning to make better turntables with less interactions, better level, graphite tone arms or whatever, and so forth. So, and I obviously I live in a very analog world with my loudspeakers. No matter what I'm saying is, I'm still feeding into a moving coil driver or a ribbon an analog signal.
Do you believe in boutique crossover parts?
I can tell you that the key to comparing those things, first of all, is you got to get the exact same values. I've had boutique parts sent to me, and they sounded different. And then when you start nulling up the value, so it's exactly the same, so your crossover behaves the same way, those differences start closing in very quickly. Now, I will tell you, though, that they typically are high voltage. That's good. Some of the resistors actually have heat sinks on them. That's great. So, and audiophile chokes you're not going to have this saturation hysteresis type problems to the degree that you have with a small gauge inductor on a cheap ferrite bobbin that saturates. So, yeah, I believe in great execution of parts. I don't believe that the amount of suffering it took to manufacture it is proportional to the quality of sound. I believe that the amount of technology that went into making the part it's sort of like ICs today. It's pretty hard to make fun of ICs like they used to in the old days.
Right.
My goodness gracious, what these things can do today. And when they started doing video op amps and they started using those as audio buffers and the bandwidth they have in those things, you're talking about so many multiples beyond the spectrum of audio that the device is effectively perfect in a null circuit. So, but I do try to use blind testing, double blind testing when possible. Earl certainly knew about that. And it's for some reason, the audiophiles get very tense often when being submitted to that type of testing though. And I have to be fair that double blind testing changes how you listen in a way that I don't think anybody wants to talk about. But I think when you look at some of the high-end magazines that have refuted the double blind test, I think you have to be fair about it. You have to look at it kind of like from a medical standpoint when they're running tests. You need blinds. You have to have double blinds. I don't know how many times I've built what I think is an improvement in a loudspeaker, and then I go back with AB my reference the next morning without knowing which one it is, and I end up picking the old one. And so you can get pretty worked up into what you're trying to achieve. And so,
do you like the modern era of, say, the Klipple NFS system, near field scanner system, where it's full polar pattern of the speaker?
Big time. Oh yeah. It's funny, but I keep referencing back to Earl again, but Earl Geddes. But what's funny is that he and Clark, they developed that Speak software, and Clark had developed the Dumax equations that have replaced the Teal Small parameters. And it was so smart because what it did was it basically used either a house vacuum or you could use positive pressure if you wanted to, but you generated parameters that were dynamic. Instead of meshing the speaker when it's sitting still, you could actually put, the equivalent of a half a volt or 20 volts through it and see how it's behaving and get dynamic variables for your speaker modeling. Now that really improved our ability to model what a loudspeaker could do. And I remember going through reams. I mean, I'm talking reams of paper, printing out polar patterns with different crossovers at different angles and different time relationships. And I have to say that was largely due to what Speak could do, because I could then introduce losses from filters. You could input the amount of resistance in your choke. And you could also see that anytime you put a big choke in front of a woofer, it would turn to crap. And what I'll give you an example of that is, say I have a box that, say I have a nice sized box. I have a woofer in there and I've optimized it and tuned it and poured it in closure. And the woofer's cornering at say 24 hertz. It looks great, looks spectacular. Now I just got to tune the top end off. Right. The second you put that choke in there, that whole curve racks forward. Your half power point shifts way forward. You get a big peak in a 60 hertz range or whatever, depending on the size of your choke due to impedance and reactance. And those are things that I take them out. I fix that problem. I transform the impedance, do all kinds of things that I don't ever publish how I do it. But there's so much to a crossover, actually building an active crossover, and having the technology, the ability to model and predict today is just tremendous.
Do you use software to model cabinet resonance, CFD, for instance, for ports, that
Yeah.
types of?
Yeah, being a chemical engineer, there's a lot of the port stuff that comes natural because we used to have what we called board entrances, and that was the biggest problem in chemical engineering is pressure drop across anytime there's a transition of fluid phase, going from a small pipe to a large pipe or a large pipe to a small pipe. Um, and a lot of people don't realize when you break down, um, uh, here again, I'm referencing Geddes, but this is funny because I guess he and Danley are probably two of the smartest guys in the business, but very few people know who they are. Um, uh, but when you take a woofer and you put it, or a speaker, and you put it in a horn, one of the things that happens, and you can develop the horns that, for example, like the Tractrix horn that Klipsch has applied and so forth. But as you're expanding, that wave is expanding at the mouth, it is a very dramatic effect when all of a sudden you take the horn away.
Right.
And example, say you were a swimmer and you kick off of a bank, and that's your radiation impedance. Acoustic impedance is something like that. And then all of a sudden you take that away. And so there's a huge difference in loading that's going on. And so that creates all kinds of bizarre anomalies. And there's a zone in front of a loudspeaker that's about 6 inches out that they ought to call it the chaos zone, because it's where it's just a mixture of all kinds of things, from edge effects to the dust cap to the cone shape to whatever. And I tend to I'll near field mic a cone to see what it's capable of, which is about finger's thickness distance typically. And then I'll come back 14 inches and look at it. And then I'll look at it again at 1 meter and then 3 meters to try to see what's really happening. So, but.
Do you have drivers designed for you, or do you do the design and then you have them manufactured for you to your design?
The answer is yes. In both cases, I will tell you, and a lot of people will say the same thing, but I'm going to prove it whenever given the opportunity. I use the best parts available. And now what I mean by that is that you won't find a part that's lower distortion or higher sensitivity with a greater acceleration factor. And if you do, send it to me, because I'll use it. And I truly mean that. I'll turn on a dime and implement it. If you looked at some of the mid ranges I use, the acceleration factor is almost an order of magnitude of some of them that are found in some very expensive speakers.
Why do you feel that parameter or those parameters are paramount?
Starting and stopping is really about what the waveform's about. And that also translates to high frequency range, if a speaker can stop and start quickly. And as soon as you take for example, a 4-inch cone and you make it a full range, your top end starts drooping. So it's a trade-off. And the other thing too is to keep in mind, loudspeakers, when you move off axis, whatever size that piston is, its top end's rolling down when you move off of its front axis. I try to design loudspeakers that are rising in response across the passband. When you step off axis, they're all self-attenuating similarly. And that's not easy to do, but that's the philosophy that we have in our designs. That's why our power response looks so good off axis.
What do you think is the contributing factor to achieving that?
Low Q drivers with rising response, suspensions that are going to be more limited as the frequency goes up. Now, for example, in our Valor speaker, our flagship, for the mid-range, I'm using 3 14-inch mid-ranges, and they have accordion edges on them. They're stiff. You might say, well, isn't that an awful lot of piston area? Well, let's see. If they're going to cover wavelengths that are easily 5 foot long, I don't think they're big. I think it might be a pair. My wife might think they're big, but the reality of it is that you need that kind of piston area if you're going to lend truth to what that microphone's picking up.
Would you also say, though, that you need that piston area if you have high sound pressure levels?
Sure. Yeah, absolutely. That's a great benefit. Dynamic range. We recently came out with a new amplifier model called the IV series, and basically IV is I is current, V is voltage, and the product basically is your power. And when you look at the amplitude required in voltage is to drive a loudspeaker to get the dynamic range. We as audiophiles love to toss around the term 24-bit. Okay, we're glad to have it. I'm, as a recordist, I'm really glad to have it because I don't know how many attempts I've made to record piano concertos, and I'm either in the noise or I'm clipping. And you can go in there and you can use compressors and try to manipulate and fix and all that jazz. But when they went from 24-bit, when they went to 20-bit, I thought I was in heaven. When they went to 24-bit, I said, I'm done. I'll never need any more than this, because you didn't really even have to be careful about setting your levels when you recorded. You just recorded and then edited from there because you knew you had enough dynamic range. And with loudspeakers, now I build loudspeakers that have sensitivities over, approaching 110 dB. Okay. And so now on my consumer line, a lot of the speakers are 90, 95, whatever. But as you get up higher and higher in the product line, and I think in one of our speakers, Eris, I think we just fib because we don't want to scare people how efficient it is. But it is so much more efficient than the Focus speaker. It's smaller brother. And Focus is known for its efficiency, but people pick up on the difference in transparency. And they say, well, why is that speaker so much more transparent? It's about the same size, da, 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 da. Well, I'm using really high acceleration factor drivers and using them in a different way in an open air figure of 8 radiation pattern. So I'm not getting sidewall reflections and so on and so forth. So acceleration is the ability to track and it gives you the bandwidth. But here again, if you have a driver that can go up very high, you can use that in the spectrum on axis, keep distortion still quite low, even though it's a larger piston, and then have it nicely rolling itself off when you move off axis. I'm not going to do that in a 2-way, but if you do a 4-way, you're going to be able to pull it off.
Do you do quality control on individual parts as well as the full assembly, or do you mainly do full assembly?
Well, let me answer that in multiple ways. First of all, we do all the driver development with the manufacturers to get the part exactly the way that we want it. Now, I use, getting back to adding more to your previous question about the manufacturing, the component parts themselves, I use Clarity Cap and Solon and some other suppliers that can supply really high voltage caps. And these are what I would consider to be pretty exotic products. I also fabricate a cap that is a 1,000 microfarad value, and people go, 1,000, what are you doing that in a passive crossover? Well, I'll use 2 or 3 of them on Focus because I got a high pass filter in there that I'm using to transform things with. And so Arnie Nudell, who just passed away, did something similar in his loudspeakers, by the way. But the parts themselves are so critical that you can't stand deviations between them. So when it's an electronic component, if they're not tight, I won't buy the parts. You can test the batch, but when you start running production and say you run 100 loudspeakers, if something was wacky, you're going to have some pretty rough days getting pair matching speakers. But at the same time, drivers, you can try to match the fingerprint of drivers. Microphones, for example, they'll talk about pair matched, but they never say that they're all perfect. They all just say that they're pair matched. Right. Well, we have a mother target curve that we shoot for in all cases. But when it comes to tweaking them and getting them to behave, to sound right, the plus or minus a half a dB in a loudspeaker is nothing the second you put it into a room, and it becomes plus or minus 15 dB on the bottom end. And then your listener distance and towing angle changes things. So its consistency is really what it's about. Now, the hinge point of the loudspeaker is the mid-range. How that mid-range translates and joins with the bottom end and the top end is so pivotal that we will indeed spend a good 20 minutes on a loudspeaker or more, getting that right. And there'll be focus 4 phase shifting circuits that are just for the transition into the tweeter. And the tweeters by nature are kind of a minimum phase driver, but you're trying to pull down a cone radiator and sum that into that. And for that to integrate properly, you have to be in transition so that the polar pattern is where you want it. You don't want it sounding great at one spot and sounding crummy somewhere else. And so there's a lot of it goes into the parts quality and matching.
What's your least expensive speaker and the cost of your most expensive loudspeaker?
Our least expensive speaker is our Studio, I believe. And they're under $2,000 a pair in regular finish, and but they're heavy. I can tell you that. And their next one up is the Caliber, and that is a speaker 60 inches tall, but it weighs over 50 pounds. So you see numbers like that too, I think, from Dave Wilson's stuff or whatever. And our pricing this is part of my North End philosophy. I come from blue collar family, and I come from work your way to the top mentality, and very much an entrepreneurial thing where if your parents had more than a 6th grade education, they were very fortunate, and most of them were immigrants or whatever in our area. And so paid my own way for college. I had a paper. I was told when I was 12 years old, you better start saving for college. So I had a paper route, and my dad worked at the newspaper for 50 years. And he set me up with a large paper route. I had 224 papers, and this is back when these things weighed a pound a piece, So I stripped out many a set of handlebars, pedaling around them. But basically, the work ethic and of how I built my company and how I set my pricing structure was, what's the point of doing what you're doing if nobody can afford it that really wants it? And what's the fun of having people that are going to throw $500,000 on an object that they don't even know themselves it's good? They just know it's expensive. And now I've satisfied a lot of those people, by the way, but I can tell you is that our pricing, our most expensive speaker is $80,000 a pair. I think that's a bunch. But by the time you sell it out the door and you package it and you crate it for 2 days and it's going to a distributor across the other side of the world, you have to ask yourself, did I come out okay on that? Because the amount of time you tie up your staff for so much time, if it takes, you got 30 days plus into manufacturing the product through all the stages. So you have to look at and I think volume is where profitability comes in. It's not, and I'm not trying to build my company's research is certainly driven by the $80,000 speaker, but it's certainly, if there's no point in doing that, if I can't trickle it down across the rest of the line.
Right. How many people make up Legacy Audio?
At one time we had 25. And then I partnered with the Allen, Oregon company, and I got the company back in my name solely in 2005, I think, 2005. 2005. And so I made up my mind when I did that I was going to not use our talented staff with special skills making grill frames, for example, for grills, um, bases for loudspeakers, which were very time consuming. So all these accessory type things, I started jobbing that out. And then I started just focusing on a team that had technical merit and people that they had to be artisans. And my goodness, it takes a long time to be a top-notch cabinet maker. And we're pretty rigorous in how we do it. And while we have a CNC that mills MDF, when it comes to once that MDF's been cut out, everything else is all handwork from that point on. So including winding the coils and building crossovers, it's all hand soldered, hand done.
So you do wind your own coils?
Oh yeah, we have to, because we've tried the other methods and they don't work. The accuracy is just not there. And one thing I can tell you about, if you get a legitimate high-end provider of coils or capacitors or whatever, what they'll do is instead of saying they're 1% values, they just write down what they are on them. That helps a ton. Hovland caps was great about that. If you got a cap and it was say you spec'd a 3 and you got back a 2.9 or a 3.3, they would write on it what it was. And so when you're building up your kit, you know what you got.
And you mentioned all your crossovers are point-to-point wired.
Mm-hmm.
So that's all done by hand.
Yes. Yeah. And we've developed an eyelet technique. I remember Jim Till used to use grommets and solder around the ring of a grommet. That always made me nervous because you're constantly resoldering that same grommet all the time, reheating the other joints. But and looking at that, and then looking at when anytime you're doing a home run like that on the ground, for example, you want it to be a high quality connection. So I started looking at, in the electrical world, how we do it. And we just finished a custom wired set of Valor system for a customer, very good guy. And he had a high-end cable supplier supply us some cable. And it's probably one of the cable manufacturer was somebody that actually had probably one of the best arguments for why their cable was better. And the way that we handled that was, and the terminations on it was pretty close to what you would do if you were rigging a large scale electrical circuit at a very high voltage. We wanted just no losses in any of the terminations. So it was very time consuming.
Do you feel as though that yielded a measurable difference?
One of our guys, Bryce Oxer, felt that there was some advantage to it. I didn't hear it enough in the field to really, but what I can tell you is that I have with our DSP that we've developed with Bomer Audio, the Wavelet processor, we have the ability to tweak and adjust it. And we get everything all locked in the time domain and the frequency, and pretty soon everything looks nice. Then you go listen to it and you adapt it. And I have a vocal booth that's in my mastering room, just adjacent to that. And the purpose of that vocal booth was, in the developmental stages for voicing, we could take someone in the booth anechoically, record them, then bring them right out of the room, and using AKG and Neumann standard microphones, and then play that back over the speakers with the person standing right between the speakers. And the idea was, there's your voice right there, and that's what you got to do. You got to get that to sound the same. So and it's 8 feet away. It's just on the other side of the wall. So
pretty cool. Where does Legacy Audio go from here?
I am continually fascinated by what DSP and Class D amplification is going to allow us to do. The idea that I could approximate what our Valor loudspeaker does by utilizing higher power amplifiers in smaller acoustic spaces and still control the radiation patterns within reason. You can't make a speaker small and have it be quick and low distortion. and it will sound like a point source and behave like a point source if you do. But there is a point where you'd like to get a speaker, say, under 4 feet in height, and you'd like to have it be one width of say a width of maybe 10 inches, and we have speakers like that now. But I'd like to get them to the point where you put enough firepower on board on that thing, with the algorithms that we have with the DSP, to actually get them to behave with better steering. Now, it's going to take more drivers to do it, because you're probably going to have differential array. For example, a woofer on the back that fires at a different time than a woofer on the front, so that they sequentially build only on axis. And then you're going to have huge equalization capability in the bottom end for the smaller cubic volume. And the transient response can still be very good in a small loudspeaker enclosure. It's just that drivers have to be able to take the power. Now, I recently ran into a situation with my Caliber loudspeaker where there was no such driver available that had adequate sensitivity, which is dynamic range. It's another way of saying dynamic range when you think about it. And with adequate sensitivity and adequate power handling or bandwidth. Now, you think about, years ago when Bob Carver miniaturized subwoofers for the world, made that a possibility. You look at how he did it, and he used an amplifier that had tremendous voltage capability. It didn't have to have high current capability because the box was so stiff. The impedance of that box caused the driver reactance to go so sky high that you just needed a bunch of EMF to push it. And so if you take that principle, then you say to yourself, well, now wait a minute, but I want dynamic range too. I want it to be able to play at 120 dB. Well, then you've got to have a whole different set of parameters for your power. So that's why this IV series of amplifiers was developed, because when 24-bit audio came on, we increased dynamic range by 30 decibels. 30 decibels. And my argument is, it's actually more than that, but in practical sense, it's about 30, is you split it. You take half of it, make your system quieter, take the other half of it and make it more dynamic.
Do you like the multiple subwoofer approach?
Yeah, but I like what the Wavelet does even better, because how can I explain this in a simple way? If I take room modes,
Mm-hmm.
they are going to do what they're going to do no matter where you put that subwoofer. And I don't think there's more than a handful of guys. Geddes knows this. Tom Danley knows this.
Absolutely.
But I can tell you, there's a lot of people that don't understand that principle. The room's going to do what it's going to do. Now, you can change the way the sounds arrive to the listener by, for example, Gressinger, who used to be the chief designer at Lexicon, a brilliant guy. There's a guy you ought to have on here, because he loves to make recordings, and he's a performer besides. But Dave, if you take 2 loudspeakers and you put one on your left, one on your right, and you lead and lag, you shift your phase shifter forward on one, shift it backwards on the other one, and you set in quadrature between them, you are putting out exactly the same amount of type of energy as if the same signal, if you will, in summation. It's going to look just like if you had one subwoofer. The only problem is the room doesn't know what to do with it in terms of making it resonate, because it's not being fed the same thing. Okay. Now there's where multiple subwoofers come in handy. Now with our wave launch processor, you don't have that problem at all, because you can go stand in a corner, it will not boom, because the way that the speaker fires and retires just like that. And that has to do with DSP and What we've done differently on that, this is a question that you would ask if you knew, but about this product. But what Wavelet does that is so unique is that when we do room correction, we do not go out to the listener position and sample a bunch of points. Oh, this side of the couch, that chair over there, and all this stuff. We don't do that. What we do is we understand that you're trying to generate a stereo sound field, and we'll make measurements on the path from the left speaker towards that position about 4 feet out. We could have used a meter. We could have used 1.5 meters, but 4 feet is a really good point where you can actually see the latency in the reflections relative to direct radiation. We already know what the speaker is supposed to be putting out based on what's going into it. So if we run a test sweep, a signal, and we sample that over a 50 millisecond or longer window, we can not only see the start of the tone sweep, but we can see when 10 hertz shows up at the microphone late, and how often does it show up late. Okay, so by doing that, you can adapt the loudspeaker. Now, I really dislike the term room correction. I've said it multiple times, but it's really loudspeaker adaptation for an environment. And you're not correcting the room. The room didn't change. So,
right. But you're not, by doing those measurements, Bill, you haven't modeled the room, have you?
No. You know what's funny? Only on that path.
Right.
Towards a listener. Yeah. What we're not doing is doing any kind of modal averaging.
Right.
What we're doing is we're looking at the arrival to the listener. And where I started, really, Bart Bomer and I came to common ground on that principle of everybody's measuring it wrong. And why I say that is that I actually paid $2,000, took a course, and went to use the datasat training thing processor, because I'd sold giant screen theater systems with made 5 channels across the front. So I had some pretty sophisticated 40 channels, 46 channels of playback I had to set up and all that. And so I wanted to use the latest and greatest correction. And through that development stage, I learned all the problems when you get into large venues of what's going wrong. And it was a lot simpler in a small room where the distance to the loudspeaker is maybe half the distance of the most dominant reflection off the sidewall and back to you. Okay. But when you get into a large theater like that, it's a different situation. Well, when I looked at things over the time domain more meticulously, I started realizing that what we've been blaming on room resonances, they're not resonances. It's not resonances that were causing the offensive bass. You have to have almost a sustained organ pedal note to really build an accumulated resonance, because transients don't hang around long enough to resonate. No, you get a 30-footer pedal note and sustain it. Yeah, you can establish a pretty good resonance. You go in a church and play it, and you'll find there's a third of the pews aren't hearing anything, and because of the cancellation nodes. But the way that things accumulate in time to the listener, you'll find out very quickly if you break it down and you look at the data as it's arriving. And our website has a really neat video on that, because it shows a slap of a pair of hands moving down the timeline in intensity versus time. But as that sweeps going this way, moving around the line, there's a 3D axis of time also that shows the history and how long that duration lasts. It's like a time energy plot type thing that you've seen in 3D before. But when you see it in real time, and you think about when you're recording music, for example, you're looking at that instant that waveform started, and you picked it up in the microphone, but you're not studying what it takes for it to decay in the room. And that's the part that was really, really lacking severely. And you can't just take something and at a listener position say, okay, I want I want apples without oranges. And then when oranges shows up, invert it and put it back in, because that guy heard apples and oranges, but maybe the person over there heard apples and bananas, and so he's going to got oranges thrown at him now. So it's a different world. So,
Can you, with your DSP system, can you get basically a loudspeaker to act the same whether the room is large or small?
yeah, that very definitely. The thing is that what we're trying to do with the design more than anything else is multifold. One is we are trying to, there's this fusion time when anything that arrives within that time window all sounds tonally like it's one. And a good way to do that is if you ever do duet vocals and a multi-track recording, and there's a point where you shift in the time enough that it sounds like two voices all of a sudden, and then you just barely back off that, and all of a sudden you got a great density in the voice. Well, if you look at how this fusion time sets up, and then you have this period where you start being able to separate reflections, lateral reflections and so forth, from the original launch. And then you get into the period where you're starting to now hear a density of reverberation. And then lastly, you hear what could be defined as echo. And that's, you're talking about path lengths over 30 feet to a boundary before you have discrete echo. And you can obviously simulate spaces by adding such reflections in recordings. But when it comes down to how do you eliminate or deverberate an environment, the software manufacturers are just now learning how to do that. And it's sort of like when they started learning how to denoise. And that's a pretty amazing thing, but you're looking for patterns. And if you can measure with a controlled signal, you have to, first of all, if you have a known entity, which helps a ton because we know exactly the signal going to the loudspeaker at all times. So if you know what that entity is, and you can then improvise the solution for it based in the time domain. And I can tell you, when we started the Wavelet project, our processor was not nearly as fast as it is today. We have it's smoking fast now.
Is it what kind of processing speed does it have?
Well, when we first started out, we were at 56-bit and 96 kilohertz.
Okay.
Correction, and now we're at 192 correction. And for those that are really familiar with DSP, know that DSP typically lived in the 48K world.
Right.
And even though you go see these motion pictures that claim to be Blu-ray, they're almost all 48K being played back. And that's okay because the DSP consoles were 48K. And Sony even got into building Oxford consoles and stuff for years, and they got out of business. But to try to up that game a little bit in their own house technologies. But another thing of interest might be to you that we, what would Sony use as their reference monitors? What do you think that they would choose for a reference monitor in, say, Sony Pictures or Epic Records or whatever? Yeah, Legacy. That's right. And they're a high-end loudspeaker manufacturer. They build high-end loudspeakers.
Interesting.
But they got floor after floor after floor of our stuff.
Do they really?
In California and in New York.
Interesting. And why do you think that is?
Why do I think that is? I think that they care so much about in that department of what they're doing. They care so much about the end result that they're looking for the best that they can get. And that's a lot of the record producers like Rick Rubin, L.A. Reid, guys that are big shots, will come to us and ask us to build something for them. And L.A. Reid, when he was out in New York, we got a picture sent to us. Oh, actually, I'm sorry. It was a magazine ad. He'd taken out an magazine in one of those highly cultured magazines that I don't even subscribe to, but Centurion. All right. And here's a picture of L.A. hugging his loudspeaker. And he paid for that. I was like, wow, okay, thank you. But No, the reason I bring that up is that the people that are really into really into accuracy, and really are knowledgeable and rely on people that are truly trustworthy, not just brand pushing. They're really trying to move the thing forward. They understand the principles, or they trust somebody that does.
Sure.
And so,
how come you haven't licensed your DSP unit to other manufacturers?
we have one friendly relationship, Burnt Bomer and I have with Gail Sanders out at Icon Audio.
Okay.
And he's building a kind of a more compact boutique product, and he's using the processor. And that's the only one. Now, I will tell you, though, that we have had a number of manufacturers trying to get the edge on the other guy and ask us to supply a processor to their customer, either by the customer's request or by them wanting to have a defiant edge over the other guy. And we'll program them for them.
Okay. Bill, is there anything that I haven't asked you that you would like to share?
I would say there's one area in audio that I kind of would like to comment on, and that is that it reminds me of the Democrats and Republicans over the last couple of years. I think everybody's ready to create a new party right now and just become the rationals or something like that. I don't know, but I think that in audio there's this intersection of enthusiasts, and it's all wonderful. We're in a renaissance of music right now. You don't have to be rich to be heard. You don't have to be rich to be played on YouTube. You don't have to have a big producer. It's upset the apple cart in the industry largely on how do you manage things in a world like that, or how do you monetize it? But it's a beautiful thing, and so there are more people showing more talent available all the time, and it's so refreshing. We're in a golden age. And the other thing too is the range of music people listen to. You used to have guys that just listened to Led Zeppelin all day, and I don't have anything against I like Led Zeppelin, but it's certainly not the only band I'm going to listen to. And there's a lot of people that were kind of that niche that it's not like that now. It's so broad, and these young people, they have the world at their fingertips. So I think that it is a renaissance, a true renaissance in music today. And I think also the audiophile, we've had this analog versus digital debate for so long that I just wish somebody rational. I wanted to just publish a paper on the topic, for example, because you can't have digital audio without analog. It just doesn't happen. And in the end, it's analog until it gets to the brain, and then it becomes digital again. And you say, what? Yeah, it is. When you look at how the neurons fire, it's in a digital pattern. And if you look at the bandwidth that they transmit in the transmission of the sound waves in the little cilia and how they're being triggered, a lot of people don't know that you only process up to about 500 kilohertz or 500 hertz in that method. And you also notice our phase abilities drop off when you get above 1 kilohertz. And the reason is there's aliasing going on, and your brain is also looking hard for high frequency information. We perceive high frequencies, but we don't hear them as high frequencies. There's carriers that are being picked up, just like if you picture waves of grain blowing in a field, but you notice that some of them are changing direction before others. And if you look at that, how the sound is being processed by the brain and through the chemical process, and then how we react to that, and the built-in latency in the brain is quite long, really. I think mine's getting longer all the time, actually. But so I guess the point I'm making is there's so much real science out there, And for anybody to take a rigid position and say, this is this and this is that, is a reflection of a lack of humility. And so that's where I'll leave it. But I am grateful for the renaissance of audio that we're in today, and hopefully these young people will take advantage of it.
Bill, thank you so much for your time. I really appreciate it.
I appreciate the opportunity. And man, you know some smart guys. I got to talk to you more. Yeah, you get Tom Danley on there. He'll tell you about speakers.
Well, it's funny you should say that. I've sent him 3 emails trying to get him on, and I can't even get a response.
Well, you know what? Tell him Geddes and Dudleston told him he needs to get on there, and
I might just try that avenue because he is certainly one that I'd love to have on.
Yeah. His designs are so radical and forward. So
and they work. That's the other thing.
That's right. Yeah. Well, I can't take my loudspeaker into the Olympics and in an open arena and expect it to sound right.
Yeah,
he can. So
it's what he does for sure.
Yeah,
I really do appreciate your time, though.
My pleasure. Thank you.
Thanks for listening. Find us on YouTube and Facebook at the Intellectual People Podcast and online at theintellectualpeoplepodcast.com. Check back for exciting new episodes.